Direct variation. A direct variation is when y varies directly with x. The equation we use is y equals kx. K is the constant of variation. We can also visualize this relationship in a triangle, where y is equal to k times x, or k is equal to y divided by x. When working with direct variations, you'll be given an equation, a graph, or a table, and you need to determine whether that represents a direct variation. You also need to be able to solve a word problem involving a direct variation. So in our first examples here, we have two equations, and we need to determine whether they represent a direct variation or not. On the left side, I have one that is an example of a direct variation, and on the right side, I have an example of one that is not a direct variation. So in order to determine whether the equation is a direct variation, we need to get it in the form y equals kx. So we need to solve for y. So in the first example, I have negative 12x is equal to 6y. I need to isolate y, so I'm going to divide each side by 6. And I have negative 2x equals y. And using my symmetric property, I'm going to rewrite that as y equals negative 2x. This is in the form of y equals kx, so this is an example of a direct variation. Number 2, to check to see whether it's a direct variation, I need to isolate y. So I'm going to minus 8 on both sides. Y equals negative x minus 8. This is not in the form of y equals kx. In fact, it's in the format of y equals mx plus b. It's in slope-intercept form, which represents a linear equation, not a direct variation. Alright, here we have some graphs, and in order to identify whether a graph represents a direct variation, what we want to keep in mind is that the graph of a direct variation passes through the origin. It passes through 0, 0. So, for number 3, two examples would be maybe a line that goes through 0, 0 that has a negative slope, and a line that goes through 0, 0 that has a positive slope. Some non-examples of direct variations, graphs of direct variations, would be a vertical line. A vertical line does not pass through 0, 0, so it is not a direct variation. A horizontal line does not pass through 0, 0. Here I have a negative slope line not passing through 0, 0, and a positive line that's not passing through 0, 0. Remember, direct variations cannot equal, k cannot equal 0, so that's why it can't be a vertical or a horizontal line. Here we have two tables, and we need to determine whether it's a direct variation. When we're given a table of values, we're going to look at y divided by x and compare the numbers. So, negative 6 divided by 2 is equal to 3. 3 divided by 1 is equal to 3. 12 divided by 4 is equal to 3. Since this number is constant, it's the same, this represents a direct variation. So it is, since they're the same. In this example here, if we take y divided by x, y divided by x, y divided by x, we see that these are all different. This is not constant. It is not the same. It's different. So it does not represent a direct variation. You also need to be able to solve word problems involving direct variations. And we have 3 steps there. To do this, we first find k, then we write an equation in the form y equals kx, and then we sub and solve, or substitute and solve. So the number 7 says, suppose y varies directly with x, and y is equal to 35 when x is equal to 5. What direct variation equation relates x and y? And what is the value of y when x equals 9? So my first clue that this is a direct variation problem is it says right here, y varies directly with x. So as soon as I see that, I like to draw my triangle. And I know that y varies directly with x, so y equals kx. Now I'm going to find x, so I'm going to draw my triangle, and I'm going to fill in what I know. And it says y is equal to 35, and x is equal to 5. So 35 divided by 5 is 7, so k is equal to 7. So that's step 1. Step 2, I'm going to write an equation in y equals kx. Well, that's easy since I have k. Y equals 7x. Step 3, I'm going to sub and solve. So I go back and see what they're asking. What direct variation equation relates to x and y? Well, this is that answer there, y equals 7x. What is the value of y? What is y when x is 9? So I'm just going to substitute 9 in for x, and y is going to equal 63. So my answers here, the first would be the equation would be y equals 7x, and y is equal to 63. So number 8 is your turn. How could you use the graphing calculator to check number 7? So one way you could check number 7 is I would take my graphing calculator and go into y equals and type in y equals 7x, my equation. Then I could look at my table and look where what's the value of y when x is 9, and right here y is 63. Here's my equation. Or I could have gone and hit trace, my graph, and trace, typed in 9, and when x is 9, y is 63.